Hey there, my name is Alejandro, and welcome back for day 285, me doing Daily LeetCode challenge after reach 1 year's worth of green contributions here on GitHub. So today's runs for April 27th, 2025. Without further ado, let's get straight into it. Okay, today we'll get LeetCode easy. Problem 3392, count subarrays of length 3 with a condition. So it is a counting problem. Okay, so 100, so n cube solution. Given an integer array nums, return the number of subarrays of length 3 such that the sum of the first and third numbers equals exactly half of the second number. Okay. For all we have to do, we can write an O of n solution for this, right? I in range n is equal to the length of nums, n minus 2. First is equal to nums of I. First, second, comma third, nums of I plus 1, nums of I plus 2, res equals 0. If our first plus third over 2 equals second, res plus or equal to 1, return res, right? Something like this. Case 1, okay, I got 0, and I got 1. Equal exactly half of the second number. Oh, I see. Equals second over 2. Okay, that's accepted. Let's submit. And there we go, bada bing, bada boom. Completion streak 285 days, consistency is key. See you tomorrow. Okay, we can probably do a few optimizations, right? We can do something like if 2 times first plus third equals seconds, then we can do res plus or equal to 1. Right, so we don't actually have to divide. That might take things a little faster. I guess they make them a little slower. You can do res plus or equal to, we can do first plus third is equal to times 2 is equal to seconds. And here we can do something like this for I comma num. You know what, let's just not make things complicated. Yeah, we can definitely do something like this, and that's fine. It even makes our solution slower. So you know what, we'll just keep it as this, we'll get rid of this, there we go, just submit this, and there we go, nice, clean, crispy O-Ven solution. We will not just touch it any further. 7ms beats 58.57%. Okay, so nevertheless, as always, in all my videos, I do a quick recap if I zero solve the problem. So for this one, we want to count the number of subarrays of length exactly 3, such that the sum of the first and third numbers equal exactly half of the second number. So what we can do is we can go through every single number in nums and pretend that that is our first number, right? Because here we're considering subarrays of length 3. So how about we go through every single starting position in nums, right, for every single index I and up to the length of nums, where we consider index I to be the first number. Now, since this is the first number, that means we need a second and a third number. So we can't go, if n is the length of nums, we can't go all the way up to n, because at the last index, and there's no second or third number. So we must go all the way up to n minus 2, not inclusive. Right, because n minus 1 is the last index, so this will go up to n minus 3 being the last actual index. That way there's always a 2 indices after the current index I, right? So what we can say is that, okay, the number at index I will be our first number, right? So first is equal to nums of I, and then our second number will be nums of I plus 1, and our third number will be nums of I plus 2. So let's go through every single index I except for the last 2 indices, because the index I will represent the index of the first number of each subarray of length 3. But we go through every single possible index I. So for I in range n minus 2, again, to allow for us to have those two numbers. But then we'll just grab those 3 values, so we'll have first, second, and third equal nums I plus 1, nums I plus 2, all respectively. And then we just want to check if the condition is true, right? The sum of the first and third numbers equal exactly half of the second number. Okay, is it the case that the sum of the first and third number is equal to exactly half of the second number? Here, notice I don't do something like integer division, because I want to make sure that I get the exact value of this, right? Note that this could be like, a decimal digit, right? It could be like 2.5, or I should say like 3.0, right? Where this is 3, but Python is smart to do like these type of integer conversions. But if you're like in another language where that might not be the case, right? For example, in C, I think if you divide, you won't necessarily have the same luck. You can always move this divide by 2, right? This is like an equation here. We can just multiply both sides by 2, right? If I multiply this by 2, I would just multiply this by 2. If I multiply this by 2, well, it's like, divide by 2 times 2 really cancels out, right? And that way you only deal with integers, and you won't ever deal with any like, floating point madness and so on if you're not using a language like Python, right? So here we can submit something like this, and it will work just perfectly. So here we say, okay, if this condition is met, then what are we going to do? We're going to augment our result by 1, right? This is initially 0. We want to count the number of subarrays of length 3 that has this value of special property. So if this property holds, then let's augment the result by 1. We'll do this for every single possible starting index I for our first numbers for each subarray of length 3 that is possible in the entire array of nums. And once we're done with this for loop, we just return our result, and there we go. Bada bing, bada boom. We have a nice and working, efficient solution to this problem. And yeah, but otherwise, that's pretty much it for this video. If you did find it useful or enjoyable in any way, shape, or form, I would highly appreciate if you left a like or comment. But otherwise, I'll catch you next one. So until then, ciao, ciao, my friends. Bye-bye.